through questions if we have any.
Yes, we've got some questions from Stella, Juan.
Okay.
Mindful of we're a bit short on time, so what kind of information is provided in the CSV files, and could you open one?
Yeah, okay. Yeah, there are many different CSV files. So I'm going to show you some of them. Sorry, I'm going back to, yeah. So for setup, we have CSV files to define how we set up our wells. I can show you one example of, in this case, what would be the treatment well. Can you see the Excel opening?
No, I can't.
Why not? Yeah. It's hopefully now.
Yep, we've got it now.
So yeah, so this is the information that you have in the CSV file for a well. It doesn't have to be this. It needs 3 of them only. So it can work with azimuth, deep, and depth, or with depth, northing, easting. So it always needs depth, of course. That's important. TVD and measure depth. And then you can work with either northing and easting or azimuth and plunge. So these are the files that we use to define that. Also, let's see if I have, you can use the CSV files to import or export. In fact, this is a CSV file that you get when you export your array. And it has the information about the position of the tools and the response of them, sensitivity, frequency response, etc. So, but also, and I didn't go through it, but I can quickly show you. You can export CSV files from InSite. Let's open, for instance, this one. You go here. You can export all this type of information in a CSV, in a text file from the events that you've processed. So basic will include basically just the time and date of our event. If we include location, we include location, then source parameters, and it can go up to include all the residual in the location. The source mechanism, it will include values of the TK components, double couple components of the moment tensor, and also some statistics on the waveform, such as signal to noise, characteristics, etc. So yeah, this is another type of CSV file that it can be exported from InSite. Hopefully this answers your questions. So can we go to the next one?
Yeah, the next one is, are the acceptable formats for raw data to import the same as those shown in the earlier drop-down menu for the already detected events?
Yes, they match basically. Yeah, you can leave the same formats as you can import as formats, and this is something that can be changed at any point. So if you have your proprietary formats that it's not in the list, yeah, as long as we have an example and you can define what's in it, we can add that to both the leach and import. Okay. So, any more?
Yep. Another one from Stella. Do you have to pre-filter raw data prior to applying the picking algorithm?
No. That's a good question. It is, you can pre-filter by default. InSite, what by default will take out the DC. That's done. You cannot do anything about it. But then you don't necessarily have to filter. So you have an option to do it or not. And you can pick without filtering. It's difficult sometimes. So that's in the options. Let me process. Oh, apologies. So if you go to processing settings, yeah. So here you have the option to filter automatically on reading. So that will filter everything as it's leached, and it will apply immediately after importing and or leaching. But if it's not selected, it will not apply. And you can auto process and do all the process without applying this filter. So you don't have to. You don't necessarily have to. It helps in most cases, but you don't have to. Okay.
Yeah, got a question from Paramita next. Can you please show again the window where you enter the sensor configuration?
Yeah. Just open one of them. Okay. Maybe, yeah, if we go here into the channel, yeah.
We've just lost you, Juan.
Oh, yes, I'm here. Okay. So yeah, here we have the channel properties. Can you hear me?
I muted myself out then. Yes, we can hear you now.
Oh, okay. Yes, so here we have, yeah, the properties. So you define, the response of the instruments is defining the channel. That was, hopefully that answers the question. You don't need to go channel by channel to define it. You can do it in a text file, but also if you right click on it, double click on it, oops, sorry. Select, yeah, all of them, and you select edit. Yeah, here, if you select all of them and you select and you click on edit, you can update the response, the sensitivity, and the response of all the channels for all the instruments. It will apply the same one for all the instruments, assuming they are all the same.
As a follow-on question from that, where
Yeah.
can I put the position of the sensors? Our sensors are attached to the samples.
Yeah. So that's in the first, if you click on edit here, so this location, that's the position of the sensor. What it's done in the channel, all channels are assumed to be the same position as the sensor is positioned, as the instrument is positioned. And this is the orientation, assuming you have a triaxial sensor, then yeah, each of them will have an orientation, but the position is done at instrument level. So the instrument position is defined here.
You've gone quiet again, Juan.
Yep, well, okay, so hopefully this answers. The easiest way if you're working with a large array probably is working with a text file, a CSV file. I can send you an example if you want of this file. Yeah, and that's probably the easiest if you have a large array. Okay.
Okay.
So
yeah, I have the question for Alexia, but it's the 3D visualizer. It's a bug, so we need to look into that and get back to Alex on it.
And I've seen it. It is a bug, I guess, on the well track being on top of the events. Yeah, we're looking into it. So yeah.
That's it for the questions then, Juan.
Okay, well, thank you very much. Thank you, Nicola.
No problem. Thank you for the presentation, Juan.
Thank you everyone for attending today. So yeah, hopefully you're all fine, and most of you probably working from home. So hope you're all safe and enjoying your work from home, and we hope to see you soon in the field. Thank you very much, and see you again. that we have.
Hi, Juan. Yes, we've got 2 questions from Ali. His first one, he was wondering in slide 14, how frequently did you update the velocity tomography? For example, did you do it every 10 minutes?
Sorry, yeah, back here, slide 14, yeah.
Yeah.
How frequently? Yes. Ooh, that depends on basically on your experiment. They normally don't take long. They take around, probably would say around a second per instrument, per wave path. And of course, it depends. During the time of the surveys, you are not acquiring data. You're not acquiring passive data. So the trade-off is you are doing a survey, but you are missing the acoustic emissions at that interval of time. So you want to space them so that you don't interrupt your acquisition for too long. For a 1-2 hour experiment, yeah, a good spacing is doing this around 10 to 15 minutes. Also, you can change the periodicity of this because normally the changes are not too dramatic at the start of your experiment, but they are more dramatic at the end. So you might want to have more frequent surveys at the end. But it's a trade-off because you need to take into account that you are losing acoustic emission data at the time you're performing your survey. So yeah, it's a good question. Good and difficult. Thank you.
Okay, his second question's on wave attenuation. It's a little bit long, so I apologise if I make a mistake. Is InSite capable of taking attenuation into account? For example, we have a hydraulic fracturing test on a rock sample, and as the injection continues, the saturation of the fluid increases and the velocity is changing, or depending on the excitement of the sensor producing the pulse. Sometimes the velocity is changing due to the attenuation. In other words, attenuation could be frequency dependent. So the question on this is, what kind of typical frequency do you suggest by which attenuation does not depend on the frequency?
Right, yes, very good question. Again, difficult one. So the only way that InSite working automatically takes into account attenuation is through the Q factor. So we can define a different Q factor per layer or a global Q factor, Q attenuation factor for layers in our model. Now, this is very general, and it's, as you say, it's very much frequency dependent. And yeah, the only way to overcome this is it's at the point of filtering our signal. And we do that, we can apologies, processing, and we define our filtering here. And filtering can be different. We can define a different filter per instrument, and we can also make it change with time if needed. Attenuation, as you know, affects very highly wave arrivals, higher frequency. And for a typical hydraulic fracturing, we tend to work in the range of between 100 and 600 hertz. As they are not very effective, we don't see much impact on them. By that, we are probably altering the P wave arrival because that's the most high effect. But yeah, to summarize, we can only work with Q factor to take into account attenuation, and yeah, defining or filter in here, which can be done individually per instrument or globally, and be adapting it with time as well. We can adapt it. Hopefully this answers your question. Okay. Any more?
Yes, Ali says thank you for that. Yes, I've got a question from Willem. Can we know or predict the creep of the rock?
Whoa. Okay. Well, not with microseismicity, I would say that's probably working together with other rest of the Itasca software. Really, this is not a predictive tool. This is an observational tool, and creep by nature is not very seismic. It's more quiet and seismic. And it's not something that InSite will work with. InSite will work basically with seismic signals, but we can combine our observations with as an input for other bits for other pieces of software such as FLAC or PFC that will use seismicity as an input, and from that we'll be able to work with a seismic behavior such as creep in signal. So hopefully this answers your question.
And that's it on for the questions, Juan.
Okay. Okay. Well, thank you, everyone. Thank you, everyone. We've been slightly over the hour that we estimated initially, but thank you very much for your attention. As I'm going to bring back our slide presentation. As always, yeah, you know where you can find us. Going to the end. Sorry. Yeah, you can find us in our website, and we will be sending you a recording of this webinar and a questionnaire for you to answer as a part. And yeah, we are here to listen to you in this email or our website. Once again, thank you very much, and hope you have a good day. Thank you.
Thank you, Juan.